This tutorial is for 4th grade, Module 5, Lesson 25. In this lesson, we're going to use the number line to help us change mixed numbers into improper fractions or fractions where the numerator is greater than the denominator. In question A, I started with the mixed number 3 1/4. That means that I have 3 wholes and 1/4 left over. What I need to figure out is how many fourths I have in all. If I look at my number line, I'm showing my hops that get me to 3 wholes. And I'm also showing that each hop consists of 4 fourths. Since 4 is my denominator, each whole has been divided into 4 equal pieces. So hopping to 1 whole uses up 4 fourths. Hopping to 2 wholes shows 8 fourths. Hopping to 3 wholes shows 12 fourths. So that takes care of the 3 wholes. And I still have 1 more fourth in my number. So I'll make that hop of 1 more fourth. That means I have a total of 13 fourths. 12 fourths make up the 3 wholes. And then I have 1 more fourth that I will add to it. That tells me that 3 1/4 is the same thing as 13 fourths. If I look at problem B, I have 2 4 fifths. Since my denominator is 5, that means each whole number on the number line has been divided into 5 equal pieces. I will show how many fifths I have in my 2 wholes. When I hop from 0 to 1, that's 5 fifths, since it takes 5 fifths to make a whole. When I hop from 1 to 2, I've now used a total of 10 fifths. And now I have to hop what is shown by the fraction of 4 fifths. So I'll count over 4 spaces and make that hop. And now altogether I have used 14 fifths. This tells me that 2 4 fifths is the same thing as 14 fifths. In this section, we're going to do the same thing without the use of the number line. The directions say convert each mixed number to a fraction greater than 1. Sample A has been done for us. We started with 3 3/4. Since the denominator of my fraction is fourths, I'm going to start by asking myself how many fourths it would take to make 3 wholes. Well, I know that 4 fourths would make 1 whole, 8 fourths would make 2 wholes, and 12 fourths would make 3 wholes. So I've got the 12 fourths, and then I need to combine the other fourths, or the 3 fourths. So I will add 12 fourths and 3 fourths to get a total of 15 fourths. 12 plus 3 is 15. My denominator stays the same because I'm talking about fourths. So I know that 3 3/4 is the same thing as 15 fourths. Let's do the same thing for problem B. Here I have 4 1/3. Since my denominator is thirds, I'm going to ask myself how many thirds it takes to make 4 wholes. Well, it would take 3 thirds to make 1 whole, 6 thirds to make 2 wholes, 9 thirds to make 3 wholes, and 12 thirds to make 4 wholes. So I'm going to add 12 thirds plus the 1/3 to get a total of 13 thirds. This means 4 1/3 is the same thing as 13 thirds. Let's look at one more example. Here I have 4 3/5. Since I'm working with fifths, I know that it takes 5 fifths to make 1 whole, and I have 4 wholes. If it takes 5 fifths to make 1 whole, it's going to take 10 fifths to make 2 wholes, 15 fifths to make 3 wholes, and 20 fifths to make 4 wholes. So I'll take that 20 fifths and add it to the fraction of 3 fifths. 20 plus 3 is 23. That means that 4 3/5 is the same thing as 23 fifths. So that number line supports how we can skip count by multiples of the denominator to help us turn these mixed numbers into improper fractions.